let's see how this electron configuration stuff is going. If you can write the electron configuration for osmium number 76, I guarantee you could write the configuration for pretty much anything. Now, I would highly suggest when you do electron configurations, you work off the periodic table. So you go to that periodic table on the very last page of your textbook, and now yours is probably marked in already, but if it's not, it takes you 30 seconds to mark up a periodic table to get you ready to do electron configurations. All you got to do is this. You put a block around the first two groups. This is the S block. The S block goes across 2 because there are 2 electrons that fill the S orbitals. Then if it's not done already, I would number down the side 1, 2, 3, 4, 5, 6, 7, and then going across the rows, that represents the energy level. So you can have a 1s orbital. Hydrogen and helium fill the 1s orbital with 1 and 2 electrons. Lithium and beryllium will be filling the 2s orbital. Sodium and magnesium will fill the 3s orbital, and so on. Now we also said for electron purposes, we're going to move helium over on top of beryllium, right next to hydrogen. His electron structure looks a lot more like beryllium, magnesium, calcium, but his properties are more like neon, argon, krypton. We'll deal with him later. But for electron purposes, I kind of picture helium as being part of the S block because it does fill the 1s orbital with the second electron. Okay, so then we kind of said if you follow your finger across that first row, there would be nothing else in the first row except for the 1s orbital. It's the only orbital in the first energy level. Then you'd go to the second energy level. You'd have the 2s for 2, lithium and beryllium. And then finally, you get over to the P block. So I'd put a box around these 6, call it the P block. And then I would highly suggest numbering this 2, 3, 4, 5, 6, 7. Because then it reminds you that as you go across from beryllium to boron, boron is not the 1p. I get that it's the first row of the P block, but the P's actually don't start till the second energy level. And so I'd highly suggest write that in there. And then you don't have to worry about remembering. Boron through neon, those 6 elements will fill the 2p orbitals. Oh, cool. Then you go to the 3s. Sodium and magnesium fill the 3s. Then I have it marked in that when I get to aluminum, I'm in the 3p. Aluminum through argon will fill the 3p. And then potassium and calcium fill the 4s. And then I get to the D block. I'm going to write that in. This is the D block. The D's don't start till the 3rd energy level. So by scandium number 21, I write in a little 3, 4, 5, 6. I make a note that the D's don't start till the 3rd energy level. And it's okay that they fill a little bit out of order and that the 4s fills first, then comes the 3d, then I go back to the 4p when I'm at gallium. It's just that we fill overall low energy to high. And sometimes it's not in the exact order of like the energy levels or the rings of the nucleus, around the nucleus. Okay, so then I'd keep filling, and the last thing that I would maybe do is put a block around these guys at the bottom. It's the F block, and they won't start until the 4th energy level. So lanthanum will be the 4F, actinium will be the 5F. Okay, cool. So, I mean, if you can mark up your periodic table, you've got it. You've got the order that the orbitals fill, and you don't have to worry about memorizing anything. What do they have this written out here as a 1, 2, 3, like a 4-step process? Please. Here's what I got to do. If I want to write the electron configuration of osmium, you obviously have to find osmium. And there it is. It's under my D. It's number 76. All right, let's do this. Where am I going to write it? I'm going to get rid of this because I'm going to need more space. Okay, so osmium. It's number 76. So here we go. We start with hydrogen, helium, 1s2. Then I go to the second energy level, lithium and beryllium, 2s for 2. Boron through neon, 2p for 6. And then I'm done with the second energy level. I go to the 3s for 2. That's sodium and magnesium. Aluminum is in the 3p. I'm going to go across 6. Then I really do get to the 4s for 2 when I hit 19 and 20, potassium and calcium. It's okay. It might be a little bit bigger orbital, but it carries less energy than the 3d orbitals. Scandium through zinc, 3d10. But now I've got it marked in, so I don't have to worry about forgetting. When I get to gallium, I'm back to the 4p. That's going to go across 6. And then I keep going. That brings me to krypton, number 36. Oh my gosh. So we go to 37, rubidium is in the 5s for 2. And then I've got it marked in by ytterbium. I'm at the 4d for 10. Ytterbium across through cadmium. Then I'm in the 5p when I hit indium, number 49. That's going to go across 6. And we're getting close. Oh my gosh. Okay, finally now I'm in the row that I'm intending to be in. Indium through xenon gets me to 54. That's the 5p6. So now I can't even fit this. I'm at the 6s for 2. That would be number 55 and 56, cesium and barium. And now technically, do you kind of notice this? That barium is 56, but 57 is pulled out to the bottom. There's lanthanum. And it's really just that the periodic table would have been too long and skinny to fit on a standard sheet of paper. And because these elements on the bottom in the F block are just not that commonly used, most are either synthetic or radioactive, really unstable. They're not elements that are traditionally studied, not in our lab. But here's 57. So at the way bottom in the 4F, lanthanum all the way across to ytterbium gets me to number 70. So that's 4F14. But now do you see 71 is back up in the periodic table? There's number 71. It's the 5D. 5D. Oh, I'm really close. So I'm at 71. And then I just count 71, 72, 73, 74, 75. Osmium. 1, 2, 3, 4, 5, 6. 3d6. Wow, that's a lot of orbitals, right? That's a lot of electrons. But I didn't have to memorize anything. It's not that it was hard. I mean, this is long. There aren't going to be any that are quite this long on your test. And if there are, there's a way to shorten it up. But it just means that you have to walk your finger through the periodic table for a couple more rows. But as long as you can understand this order that the orbitals fill as it's predicted on the periodic table, they might get longer, but they don't get harder. Now, here's the other thing I want to point out. Here's kind of where we ended things. This is our final section of the electron configuration. It was like the final row. We call them periods going across. Once we got to the 6th period, it was the 6s2, then we went down and picked up those 4f for 14, and then we came back up for the 5d6. Okay, so that's cool, that's where we're at. But now at the bottom here it says, finally write the complete configuration so that the subshells in each principal energy level are grouped together. I'm going to make a note right here and say optional. Oh, whoopsies. Optional. Okay, so here's what they did. When you get to like the D's. And you know how the D's feel a little bit out of order? So for example, like right in here, they listed 3D10 and then 4s2. Well, technically that's not the order that the orbitals will fill. So I'm going to tell you this, I don't do that. I don't do this grouping the orbitals so that they're all in the same energy level. I leave it like this. This is A-OK. This is happy face. A+. A+. Totally fine. You do not need to regroup the orbitals. And in fact, this I think is a little bit more standard. It's okay if the orbitals aren't all grouped by their energy level. This shows me the order that they fill. Now there might be one time when I can think of that it might be nice to have them all grouped together by energy level, but we've got the big numbers out in front that tell us what energy level the orbital is in. So I don't know that it's that big of a deal. Like, why would I rearrange everything? I mean, this was a lot of work, right? And so if you want to leave it like that, totally cool. And in fact, I probably will. More often, I'm just going to leave it like that. I have no problems with this. It goes increasing energy level, right? Okay, so let's try one more. Number 30. Using a periodic table, write the full configuration of bromine so that all subshells in each principal energy level are grouped together. No, I'm not going to do that. We're going to rebel. I mean, if you want to, you can. But it's not required, and it's not standard. It's not necessary. All right, so let's do bromine. I'm going to use my periodic table, and let's rock some bromine. So first we got to find it. There it is, number 35. So I'm going to do this one on the bottom. Bromine. We just start at the beginning and we're going to walk our finger until we hit bromine. So I always start with the 1s for 2. And then we go to the 2s, lithium and beryllium, 1 and 2 electrons. Then I'm going to follow across to the 2p for 6. That gets me from boron through neon. That's it for the second energy level. Then I go to the 3s for 2. The 3p all the way across for 6. Now I'm at argon. Okay, so here we go. I'm going to say 4s2. That's potassium and calcium. Then I'm in the 3d for 10. That's scandium through zinc. I'm at 30 electrons. And now I have it marked in 4p. Bromine, 1, 2, 3, 4, 5. Bromine is the 5th element across the 4p. Now there are 2 ways that you can double check your answer and see if it's right. Option 1 is to count all the electrons. If you count all these superscripts, you should get the right number of electrons for that element. So this is element 35. I've got 2, 4, 10, 12, 18, 20, 30, 35. I've got 35 electrons. The other thing you could do, or if they ever gave you a configuration and said, what element is this? You could do that. You could count all the electrons, or you could just look at the last orbital and say, okay, 4p5. So I want to find the 4p and then go across 5. Yeah, there it is, 4p5. P block, 4th energy level. It's not the 4th row, technically, of the P block. And yeah, 5th element across, bromine. It is A-OK to leave it like this. Now, if you want to, you could group them by energy level, which would just mean that if you really want to, you don't have to. But you could take like this 4s2 and just move it so that it's right in front of the 4p5. That's what they're referring to by group them by energy level. But this shows the true order that the orbitals fill.